Hello and welcome back to the AI Masterclass. In today's tutorial, we're talking about the reparameterization trick for variational autoencoders. So let's have a look. Here we have our variational autoencoder, and as we discussed previously, effectively this is an autoencoder where we replaced the bottleneck, which consisted of one latent vector on its own, with a distribution. So now we're taking our inputs, and rather than mapping them straight onto the latent vector, we're mapping them onto a mean vector and a standard deviation vector which constitute our distribution. And from this distribution we sample the latent vector. So every time we sample the latent vector, we get a slightly varying result, and then we use the sampled latent vector to perform the decoding. And so that allows us to accomplish that stochasticity or randomness that we are looking for in the variational autoencoder. Now, how do you actually train a variational autoencoder? What will happen when we run backpropagation? Well, this is what will happen. We're running backpropagation. It goes here, and then right away, as soon as it gets to this sampled latent vector, it's going to encounter a problem because there is stochasticity in this latent vector, and so basically we're sampling it, and we cannot run backpropagation through this stochastic latent vector. So that's a problem, and how do we resolve this problem? Well, this is where the reparameterization trick comes in handy. What is suggested is quite a simple solution. What we're going to do is we're going to take this latent vector, sampled latent vector, and we're going to represent it in the following way. Z, our sampled latent vector, is actually going to be the combination of the mean vector, the mu, plus the standard deviation, the sigma, multiplied by epsilon, where epsilon is actually going to be the stochastic node. So rather than performing the stochasticity here or performing the sampling here in this latent vector itself, we're going to separate out the sampling into its own separate node, and that way is going to allow us to run backpropagation. So let's have a look in a schematic, or at a schematic representation of this, so it becomes a bit clearer. So here is our original variational autoencoder. As you can see, we're taking the mean vector and the standard deviation vector. We're using them inside the latent vector, or the sampled latent vector. We're using them inside here to perform the sampling of the latent vector, and then we're proceeding with the decoding. Whereas that's where the problem occurs. We cannot go, backpropagation cannot go through this stochasticity. So this is where the reparameterization trick comes in handy, or comes to the rescue, because what we're doing now is, rather than doing the sampling within this node, within this vector, we're actually separating out the sampling into its own separate node. So epsilon is just going to be a way for us to introduce randomness into this equation. So it's just going to be a standard deviation, a standard distribution with a mean of 0, standard deviation of 1. There's nothing special about it. We don't actually need to train it. Whereas everything else that we do want to train is easily accessible to backpropagation. So backpropagation just simply runs through it because there is no randomness here. In fact, the randomness is separated out in its own node. And as we can see here, we don't need to worry about this. We don't want to train it anyway. Whereas everything we do want to train is very, very straightforward for backpropagation. So that's how the reparameterization trick works in a nutshell. You will actually see all of this in the practical tutorial. So when you'll be following along with Adlan with the code, you will create this mu vector, the sigma vector, the epsilon vector, and then all of the code that you're putting together, you'll just remember this diagram, and it'll all come together in your mind as well. Yeah, so that's the intuition behind reparameterization. If you'd like to learn more about it, then there's a paper on arXiv, which is called Autoencoding Variational Bayes by Kingma and Welling. And this is where the reparameterization trick originally first was introduced. So check it out if you want to learn more, and I look forward to seeing you back here next time. Until then, enjoy artificial intelligence.